We're going to look at an introduction for Monday's work. We've learned that the greatest common factor, GCF, is the largest factor that two or more terms have in common. For people who have a solid sense of numbers, there are people like that where finding the GCF, they just kind of play around with the two or three numbers in their head till they figure out what the biggest number is that divides into all of them. For other students, it is a bit more intimidating. And so what we're going to do is look at a method or methods that can be used to define the GCF that never fails, or kind of give you something that when you're asked to find the GCF on Monday, because you are going to be asked to do this, that you at least have a strategy that works for you. So first thing we're going to do is find the GCF of two numbers using factor trees. And I told you that this is going to be popping up in a few weeks. It actually pops up now. So 18, what you do again is you start at 1, and 1 times what makes 18, which is 18. 2 times what, which is be 9. 3 times 6. 4 doesn't go. 5 doesn't go. 6 is right there. If you don't know how to do the numbers, and what you can do is just simply do 18 divided by 1. Notice that you get that answer. 18 divided by 2. Notice you get the number that goes with it. 18 divided by 3. Notice you get the number with it, and you know to skip a number whenever you get a decimal as an answer. So that's pretty much how you do the factor tree there. Then you do the one for 24. Of course, 1 times 24 is 24. 2 times, again, if you don't know what it is, do 24 divided by 2. I don't know why I keep hitting the wrong button, which is 12. 24 divided by 3, which is 8. 24 divided by 4, which is 6. If you don't know, do 24 divided by 5. Notice you get a decimal, so you can stop, and the reason I know I can stop now is because 6 is my next number and 6 is already over there. And so when you're looking for the GCF, you want the biggest number that's in both. So starting here, 24 is not in both, 12 is not in both, 8 is not in both, 6 is, so your GCF for those two would be 6. And yes, that is a lot of work, but in terms of when you first start, you at least need something that's going to get you the answer. And this is one method you can use in terms of factor trees to find your GCF. The bottom line on this is that you have to find the GCF, and if you don't, then you're not even going to be able to get the question right. So that's the general idea. B, there is a way to do the GCF using a calculator, but it takes a little bit of sense and a little bit of thinking. What I do first is I always take the smaller number first and put it over on top of the bigger one. And then I use the fraction or the calculator to reduce it. So I put 18 over 24. I don't need parentheses because it gives me an answer anyway, and I'm not doing anything with it. And remember that what we do next is we hit the math button, and then we convert the fraction. And what it does for me is it reduces the fraction. And so the other way to do it is ask yourself, what are you dividing 18 by to get 3? If you don't know that answer, just do 18 divided by 3. And see that the number that's missing here is 6. Notice that's your GCF. Same thing as if you did 24 divided by 4, which also gives you that you divided by 6. So this way works just fine. This way works just fine. You just have to kind of pick whatever one works for you, because outside of that, you just have to kind of know your number facts, and you need to make sure that you understand how to work through the numbers yourself. 56 and 32 using factor trees. Again, 56 over here. 1 and 56 is a given. 56 divided by 2 is 28. I don't think 3 goes in, but again, it doesn't hurt to check. 56 divided by 4 is 14. 56 divided by 5 is 11. Nope. So 56 divided by 6. Nope. Divided by 7 is 8. And notice that my next number is 8, so I can go there. So here's something else you can do for your GCF. Instead of making that factor tree for 32, you could just check these numbers to see if they go into 32. Of course, 56 doesn't go into 32. 28 doesn't go into 32. 14 doesn't go into 32. I believe 8 does. Notice I'm starting from the big side first because I'm looking for the greatest common factor. Don't start from the low side, you'd start from the high side. But either way, I already know the answer is 8, but that's because as you get used to it, after you make your tree for 1, you can just kind of say which one of these goes into 32 and figure it out. But if you were to make it for 32, you'd get 1 and 32, 2 and 16, 3 doesn't go, 4 times 8, and I think that's it. And of course you see 32 isn't there, 16 isn't there, 8 is your answer. Again, if you were to do it using a calculator, then you always take the smaller number first, 32 over 56, and reduce the fraction first, so 32 over 56, and then math, enter, to see if that turns into 4/7, and find out what number you are dividing by here, just by simply either saying what do I divide 32 by to get 4, or you could just do 32 divided by 4 directly to get the answer of 8. And again, that is going to be your job to kind of figure out. Again, hopefully one of these methods stands out to you as useful. Next week, as I said, you'll be expected to perform one of these on your own. A lot of you are having issues with saying you don't remember stuff. You guys stop doing that. You're out of middle school, you're out of elementary school, and you are becoming an adult. There is no excuse to forget something that you've already done maybe 2 days ago, maybe if it was a week or 2 weeks or 3 weeks ago. But if it's something you just did, it just means stop being lazy. Stop trying to, baby your way out of it. You have to start working to try to remember this stuff. Another issue with this unit is that we will learn to expand the GCF to include variables. In order to help you understand, I will use one of my silly story methods to help you make sense of it. So just kind of act as if the story is true, and hopefully when it's over you'll kind of understand what I'm talking about when I make my point. 2 people, John and Tyra, went to a flea market on Sunday. Both of them went with a small amount of money, but they really enjoyed buying unique items. One store was selling 2 of the same items, so both of them went shopping. They found something small. They actually found 2 of the same thing, and both of them wanted it. So pretty much if you're talking about going to somewhere and 2 people are buying something, then of course it should cost the same thing. In order for the seller to make money, he knew he had to negotiate with them. Because of course at flea markets that's what you can kind of do. You can say, well, I don't want to spend $5, I'd rather spend $1, and then you kind of negotiate and figure out what you're going to do. So what the person was able to do was determine that John had $5 through whatever talking or whatever. But again, in the end, he knew that John had $5 left to spend and that Tyra had $3 left to spend. He also knew that of course you had to charge an amount that both of them had. If you charge $5 for this item, then John can buy it, Tyra can't. If you charge $4, John can buy it, Tyra can't. And you have to assume that they're not going to share money. That's how you lose business. He also wanted to make as much as possible. And so his situation as the seller was to try to pick the number that would make both of them buy it, but at the same time that would make him the most money possible. For example, if he charged them both $1, both of them could buy it, but he could also charge them $2 and both of them could buy it. But even so much more, he could say, well, who has the least, and find out that Tyra has the least and just charge whatever Tyra has. So if you're talking about how much he could charge so both of them could purchase it, he could charge $3 because Tyra could spend all of her money and then John would have a couple dollars left. And so that's pretty much what you're doing whenever it comes to variables. Think about it here. What if John had $2 and Tyra had 11? Again, you want the most that you can possibly get without passing up someone. You would always pick the lowest amount, so he would charge $2 for it. Don't charge 11 because only that person could buy it. You buy it, charge 2 because both of them could buy it. What if John had 6 and Tyra had 1? Again, what you do is you look and say, well, what's the lowest amount that one of them has? And it's 1, so you could charge them $1. Again, the pattern is you pick the lowest of whoever is there. So you just, again, if you have 2 people with money, you pick the lowest amount that the 2 people have, and that's what's going to go. So this pattern does work with the sum for variables. The GCF of 2 terms with a common variable is the amount that both variables have in common. So look at this, GCF of x squared next to the 5th. This is like him having $2, him having $5, or her having $5. And what you say is that what you can take, or what they have in common, is 2x's. Notice again, you're just simply picking the lowest number. GCF of y to the 7th and y to the 4th, you are picking the one that is the lowest. They both have at least $4. So again, that's the process that you're going to be adding into your steps next week. And then you want the GCF of x to the 5th y squared, x to the 2nd y to the 8th. Again, you're talking things that they have in common. Both of them have an x, so you can say that they have an x in common, and you do that for your x's and say how many x's can you pull off for both of them. And of course, if that has 5 and that has 2, you can pull off 2. They both also have y's, so you look at your y's and say if both of these have y's, how many can I pull off of both? Of course, you would say if that has 2 and that has 8, that you can also pull off 2. And so that would be your GCF for these two. Even though it gets more and more complex, you simply break it down from number to variable, kind of like what we did last unit with our multiplication and division. We worked the sign out by itself, the number out by itself, and then the variables out by themselves. And next week what we're going to do is put it all together. We're not going to do it right now. We'll do one quick example. But it is important that you still know how to find the GCF of numbers and variables in the same problem. So one quick example before I close this message out is to find the GCF of 28x to the 4th y and 21x squared y to the 5th. Again, the first thing you want to do is look at the numbers and say I need a GCF of 28 and 21. Now whether you use the factor trees or the calculator, for me I think the best thing to use is the calculator. If you don't know how to do it in your head, do 21 over 28, reduce that off to the side and figure out the 21 over 28. Notice I'm off to the scratch paper. Turns into 3/4, and ask yourself what you divide 21 by to get to 3. If you don't know, do 21 divided by 3 to find out that your GCF is 7. So 7 is your common number. Now you look at your x's and you say how many x's can I pull off of both of them at the same time. Again, what's the most I can charge both of these so that both x's come out, and the most I can charge is the lowest number, which is x squared. And then you notice that both of them have y's, and you say what's the most I can charge. This has 5 y's, this has 1. The most you can charge is 1. And so what you will be doing is simply pulling off that GCF. Now there is going to be more work to this next week, but I needed to make sure you at least saw that so that next week whenever we go you at least have some sort of background for it. Other than that, enjoy your weekend.